Hey, it's me. Hope you are doing well. In this video, we will learn about 1.3 IP addressing and subnetting. We will cover all objectives mentioned in the course. So let's start with our first objective. Explain the difference between IPv4 and IPv6 addressing. As you can see here, an IPv4 address is a 32-bit address that uses dots to separate four 8-bit numbers. Each number can be between 0 and 255. IPv6 address is a 128-bit address that uses colons to separate 8 16-bit numbers. Each number can be between 0 and 65535. Now, why do we have IPv6? Well, simply because we ran out of IP addresses. To understand why, look at this list of IP addresses. They are all within the same network range. These are just examples, but there are millions more in this range that are currently being used. As you can see, this range ends at 255.255. 255.255. Now if we add another IP address here, we run out of valid IP addresses. Remember, each number can only be from 0 to 255. You cannot go beyond that. However, if we were to use IPv6, we would not run out so soon. Let me show you. Here is an example of a valid IPv6 address. This one happens to end at 65,535, but remember each number can be between 0 and 65535. If we wanted to find the next available IPv6 address, we would simply increase this last number by 1. Now we can keep going with this numbering scheme for a very long time. We could even go beyond 65535. Now what about these ranges? Well, these are referred to as private IP addresses. You can read more about them online. For now, just know that they are reserved for internal use only. You should never try to connect to the internet directly with one of these IP addresses. Next, let's look at public IP addresses. A public IP address is an IP address that is assigned to your router by your internet service provider. For example, if I try to find out my public IP address, I can use a website like "What is my IP address?" And then here under the public IP address, I see 125.213, 243.189. So this is my public IP address. Every device connected to this router has access to the internet using this IP address. However, as far as the internet is concerned, all traffic coming from my local network is coming from a single source, the router. The router is performing network address translation, or NAT for short. This is great because it allows us to have millions of devices within a local network and they all share a single public IP address. It also saves us IP addresses because we don't need one IP address per device. Let's take a closer look at the IP address. 125.213.243.189. The first three numbers tell us which network the IP address belongs to. The last number is unique within the network. In other words, it identifies a host. We call this last number the host ID. So let's move on to our next objective. Explain the purpose of a subnet mask and show how it can be converted into CIDR notation. A subnet mask tells us which part of the IP address identifies the network and which part identifies the host. It is always the same size as an IPv4 address, 32 bits. Usually, the subnet mask is written in dotted decimal format, but there is another way of writing it called classless inter-domain routing, or CIDR for short. With CIDR, we use a slash and then a number to represent the subnet mask. To convert a subnet mask to CIDR, perform the following steps. Step 1. Count the number of continuous ones from left to right. Step 2. Replace the periods with no characters. Step 3. Convert the binary value to a decimal value and write it after the /. For example, this subnet mask is 255.255, 255.0. Here, step 1, we have 24 ones. Step 2, removing the periods gives us 25525525550. Step 3, to convert CIDR back to subnet mask, perform the following steps. Step 1, take the number after the slash and convert it to binary. Step 2, add 255 as a default value to any missing bits on the left. Step 3, replace the periods with no characters and the result is your subnet mask in dotted decimal notation. For example, let's convert this CIDR address 10.1.1.1/24 back to subnet mask. Step 1, 24 in binary is 00011000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000. Step 2. Adding the default bits, we get 255.255.255.0. Step 3. Replacing the periods with no characters gives us 255.255.255.0. Therefore, the subnet mask of 10111/24 is 255.255.255.0. Next, we will learn how to calculate subnets manually. There are two things you need to learn. First, you need to learn how to find the range of a set of numbers. For example, what is the range of numbers from 1 to 255? It's simple. You just subtract the first number from the last and add 1. That is 255 minus 1 plus 1 is equal to 255. How about the range of numbers from 1 to 10? That is 10 minus 1 plus 1 is equal to 10. Now what about the range of powers of 2? Here you need to use this formula. Range equals 2 to the power n minus 1, where n is the number of bits. Using this formula, the range of numbers from 1 to 4 is 2 to the power 2 minus 1 is equal to 3. The range of numbers from 1 to 8 is 2 to the power 3 minus 1 is equal to 7, and so on. The second thing you need to learn is how to find the number of hosts in a network. We need to use this formula. Number of hosts equals 2 to the power h minus 2, where h is the number of usable host bits. Usable host bits are the total number of bits in the host field minus the number of bits used for subnet. To find the number of subnets in a network, we use this formula. Number of subnets equals 2 to the power s, where s is the number of subnet bits. Let's look at some examples. In this first example, we have 255.255, 255.0 or 24 in CIDR. Our goal is to find the number of subnets and the number of hosts in each subnet. The first step is to identify the number of bits used for subnet and for host. From the subnet mask, we know that the first 24 bits identify the network and the last 8 bits identify the host. Therefore, we have 24 subnet bits and 8 host bits. Now we can find the number of subnets by using the formula number of subnets equals 2 to the power s, where s is the number of subnet bits. In our case, we have 2 to the power 24 subnets, which is 16,777,216. Next, we can find the number of hosts in each subnet. By using the formula number of hosts equals 2 to the power h minus 2, where h is the number of usable host bits. In our case, we have 2 to the power 8 minus 2 hosts, which is 254. In this second example, we have 255.255 to 0.0 or 16 in CIDR. Our goal is to find the number of subnets and the number of hosts in each subnet. The first step is to identify the number of bits used for subnet and for host. From the subnet mask, we know that the first 16 bits identify the network and the last 16 bits identify the host. Therefore, we have 16 subnet bits and 16 host bits. Now we can find the number of subnets by using the formula number of subnets equals 2 to the power s, where s is the number of subnet bits. In our case, we have 2 to the power 16 subnets, which is 65536. Next, we can find the number of hosts in each subnet by using the formula number of hosts equals 2 to the power h minus 2, where h is the number of usable host bits. In our case, we have 2 to the power 16 minus 2 hosts, which is 65534. In this third example, we have 255.0.0.0 or 8 in CIDR. Our goal is to find the number of subnets and the number of hosts in each subnet. The first step is to identify the number of bits used for subnet and for host. From the subnet mask, we know that the first 8 bits identify the network and the last 24 bits identify the host. Therefore, we have 8 subnet bits and 24 host bits. Now we can find the number of subnets by using the formula number of subnets equals 2 to the power s, where s is the number of subnet bits. In our case, we have 2 to the power 8 subnets, which is 256. Next, we can find the number of hosts in each subnet by using the formula number of hosts equals 2 to the power h minus 2, where h is the number of usable host bits. In our case, we have 2 to the power 24 minus 2 hosts, which is 16,777,214. There are also some great tools out there to help you with subnetting. My favorite tool is IP Subnet Calculator from SolarWinds. Here you can enter a network IP address and the subnet mask or the CIDR. Then click on Calculate and it will show you all the details. Another website I like to use is Subnet Online. Hopefully now you know the basics of IP addressing and subnetting. In the next video, we will learn about 1.4 default gateway and 1.5 DHCP. Make sure to watch them. Don't forget to like this video. And I will see you in the next video. Thank you for watching.